Good afternoon. Now we will go to the third example of test 1. So we have determined the moment of resistance of T-beam with the following data. So we have given width of flange 100 mm, sorry 1000 mm. So we have BF 1000 millimeter. We have given depth of slab. So we have DF 100 millimeters. Width of web, we have 300 millimeters. Overall depth 500. So this overall from this to the end of fiber. So this is 500 mm. Effective cover 50. So we have D equal to 500 minus 50, which will be 450 millimeters. Now you assume neutral axis in flange. Assume neutral axis in flange. So we have Cu equal to Tu. So as it is in flange, so we have it as a rectangular section with width as BF 0.36 FCK XU into BF equal to 0.87 FY AST. Now you can see AST, we have these are 5 bars of 25 torr, and we have these as 2 bars of 20 torr. And from this, if we will calculate value of AST, then we have for 25 torr 2454.73 plus 20, we have 628.32. And from this, we will get total steel 3082.69 mm square. So we will now find XU equal to, I will directly put 0.87 FY AST 3082.69 divided by 0.36 FCK into BF is 1000. And from this, we will get value of XU 154.58. 154.58 millimeter greater than 100 mm. And therefore, assumption is wrong. Therefore, assumption is wrong. Now we will consider next, assume 3/7 of XU greater than DF, which gives us constant stress in flange. Constant stress in flange. And then we have formula 0.36 FCK XU. Now keep in mind it becomes BW equal to constant stress 0.45 FCK in bracket width we have BF minus BW because BW already considered over here into DF depth of flange which is equal to 0.87 FYAST. 0.87 FYAST you calculate here only and will use everywhere that value. Now we have 0.36 FCK 20 XU. We have to find out BW is 300 plus 0.45 FCK is 20 into 1000 BF, which is BW 300 into DF 100, and that is equal to, so this value I have calculated 1113 into 10 raised to 3. Right here 1113 into 10 raised to 3. So this is value of this data. 1113 into 10 raised to 3. So every time we need not require to calculate it. And now just I will rub this part. So now we have value of xu from this. So I will just put value of xu. So xu equal to, now we have 1113 into 10 raised to 3, and value of this portion we have 630 into 10 raised to 3 becomes minus, and 0.36 FCK into BW we have 2160, and that is equal to 223.67. 223.67. Now we have to find out XU max, which is equal to Fe415. We have 0.48 D. D is 450. And if we calculate this value, this comes 216 millimeter. Now this value is less than XU, and therefore section is over reinforced. But over reinforced section is not allowed in LSM, and therefore we have XU equal to XU max, and we have to keep this value 216 millimeters. And now we have to find 3/7 of XU, which is equal to 3/7 of 216, and this value 3/7 of 216 is 92.57, which is less than DF, that is 100. And then our stress is not uniform, and we have to use YF. YF we have 0.15 XU plus 0.65 DF. And 0.15 XU we have 216 plus 0.65 DF we have 100. And from this we will get value of YF, that is equal to 97.4 millimeter. You can see this is less than DF, that is 100 millimeters. And therefore we will find MR, that is equal to 0.36 FCK XU BW in bracket D minus 0.42 XU plus 0.45 FCK into BF minus BW into YF in bracket D minus YF by 2. DF we will replace by YF. And now we will get value 0.36 into 20, 216 into B is BW is 300. D we have 450 minus 0.42 into 216 plus 0.45 FCK 20 in bracket 1000 minus 300 into 97.4 YF D minus YF by 2. And from this we will get value of MR, which is equal to 167.63 into 10 raised to 6 plus 246.25 into 10 raised to 6, and that value we have equal to 413.88 into 10 raised to 6 Newton millimeter. And from this we will get value of MR is equal to 413.88 kilonewton meter. So likewise, we have to solve problem of flanged section. Important XU you have to compare with XU max, and over reinforced sections not a load in LSM, and therefore we have to use limiting section. Therefore, take limiting section. Limiting section, and we know we have limiting, that is x max value. So likewise, we have to solve the problem. So now we will stop here only. Thank you.